Hello everyone, welcome to my channel. In this video I'm going to build a small network, a new lab 3. In lab 2 I built a basic network which had 2 access routers, 4 PCs in 4 different VLANs, and we verified the intra-VLAN communications and also the DHCP on the router. So in this lab, we are going to expand actually lab 2, and we are going to add another location as the head office, and we have 2 branch offices. So let me show you how the topology of this network looks like. So this portion of the network is exactly the same as what we had in lab 2, but in lab 3 we are going to add another location, which is the head office. So in these 2 branch offices, Montreal and Toronto, they are connected with a serial link to each other, 128 kilobit per second serial link, and there are serial links going to the head office, the new location. Again, we have 2 access switches, and we have 4 PCs here, or our clients, PC A, B, C, and D. Again, these PCs are in different VLANs, VLAN 10, PCB in VLAN 20, PCC in VLAN 30, and PCD in VLAN 40. And we have also one router in the head office, which is connected to the ISP. And actually, here we can see a PC, but actually it is just a loopback one of a router located in the head office, which represents our internet access. So we have also 2 branch office routers that are connected to the head office router, and we are going to verify the connectivity between these PCs and the PC located in the head office, and also connection from the PCs in the branch offices to the internet. And also keep in mind that all these locations are using different blocks of IPs. So in order to make the communication between these branch offices and the head office, we are going to use a dynamic routing protocol, OSPF, between the branch offices and the head office. So let me show you what IP schema I'm going to use. So here, as you can see, in the headquarter or the head office, I have the loopback 1 configured on the head office router, which is 1111 with the subnet mask I255.255.252. Actually, this is just a loopback interface representing the ISP connection, which is on the router. But in reality, we will have a connection from the router going to the ISP. We have gigabit 01. We have 2 serial interfaces. As you can see, I'm using the this block of IP address 172.30.1.1 for the connection, which is going to my PC in the head office. I'm using this block of IP addresses with the subnet mask of 252/30, 192.168.1.1 for connection to the branch office B1 in Montreal, B2 in Toronto. We are using this IP address. And if we go to the branch offices, for example, Montreal, you can see I'm using a different block of IP addresses for VLAN 10, VLAN 20, for serial communication between the head office and the branch office in Montreal. I'm using this subnet, and I'm using this subnet for the serial link between the Montreal and Toronto office, connection to the headquarter and connection to B2. Also, we're going to configure actually DHCP. So in Toronto, again, we can see I'm using a different network for VLAN 30, for VLAN 40, and just I'm gonna explain shortly how I came up with this subnetting and IP address. This IP address I'm using /28 255.255.255.240. I'm gonna show you how I have calculated the block of IP addresses for different VLANs, as well as so this actually block of IP addresses is very straightforward. /30 when we want to have only two hosts in the network, we use a /30 or 252, because in the serial link between for example, the Montreal, the Toronto office, and the headquarters, we only have two IP addresses on each side. And also we will have DHCP configured on each branch office routers. So we will have DHCP here that will distribute IP addresses to VLAN 30, 40, and 40, and DHCP here to distribute IP addresses to the PCs in VLAN 10 and VLAN 20. Okay, how I came up with these blocks of IP addresses, as you can see, I'm using the block of IP address for branch offices in the range 172.17.1, let's say 0 and 240. For the head office, I'm using just a classful IP address. As you can see here, we have 172.30.1.10. So we are using 172.30.1.10/24. So the same IP, the same subnet is configured on this router. If we go up and look at the IP address, so you can see it's /24. So I'm not doing the subnetting in the headquarters, but in the branch offices, I'm doing the subnetting for different VLANs, VLAN 10, 20, 30, and 40. So let me show you how I came up with this block of IP addresses. So they are in different networks, although the subnet mask is the same because I'm doing the subnetting. So the IP address in VLAN 30 and 40, they are in two different VLANs or two different networks. So this is how I have done the subnetting for this network. The block of IP address I'm using is 172.17.1.0 with the subnet mask 255.255.240. So in total, if you change it to the binary, you can see that we have 28 bits, 28 bits for 1, which represents the network portion, and this part represents the host portion. So the CIDR notation is something like this. So in this network, we will have 2 with the power of n. The number of zeros is the number of hosts in each network, and because we are borrowing some bits from the hosts and allocate them to the network, that's how we do the subnetting. So here we have 2 with the power of actually the number of ones, and actually this is a typo here. 2 with the power of 4 is 16 networks we can have. So our network IDs will change if you subtract 256 from if you subtract 240 from 256. 16 is the number that you can see our network changes every 16 bits. So from 172.17.1.0, then 16, then 32. Okay, so this is how I came up with 16. So because you can subtract 240 from 256, you come to 16. So if you add 16 to the last octet, so this is how you can create 16 networks. We have 16 networks with the network ID of 172.17.1.0. The range of usable host range is from 11 to 114, and the broadcast address is 1.15. Again, the next network ID is 116. The usable is from 170. Now let's see and compare this with our uh, IPs that I have set. For example, if I go to VLAN 10 and 20 and look at this IP address that I have set here. So for VLAN 10, I think if I put it here, it's better. So for VLAN 10, you can see that I put the first usable IP address for VLAN 10, and actually this interface is a sub interface which represents the default gateway of PCs in VLAN 10. The next one for VLAN 20, I have started from the next range of IP from .17. And if I go to VLAN 30, I have chosen the IP which is 129. So 129 actually is this one. So I have started from this. So actually I have skipped these ranges. So 129 is from this range. And 145 is from this range. So this one for VLAN 30, this network ID, this for VLAN 40, this one for VLAN 10, and this one is 4. So they can see that they are in 4 different VLANs, and the first usable IP address I have assigned to the default gateway of the host. So the default gateway of the hosts are actually these IPs. Okay, so that's the IP schema that usually we have to plan in advance before going to the design of the network. So I'm going right to the configuration. I'm using EventG. This is actually, I have built the physical network. I'm using the, actually just to show you, I'm using the Cisco IOL for the routers, Cisco IOL images, and I'm using the Cisco VIOS switch for the switches. For the PCs, again, I'm using Windows Server just to verify the connectivity between the PCs and the ISP. So I'm gonna just turn them on and I will start the configuration. So the interface numbers, just to tell you, the interface numbers are not the same as what we see in the topology. In the topology, we can see like S000, but we don't have these interface IDs for these routers. But it doesn't matter because we need just to configure these interfaces based on what we have here. Okay, so I'm gonna turn on my internet working devices. I'm not gonna turn on the clients for now. After I do the configurations, just for the verifications, I will turn on the devices. So I'm gonna connect to my switches and routers. I'm using the secure CRT to access actually to the console of these switches. Sorry, I just okay, just let me close this and reopen it again. Okay, so you can see that my systems are booting up. Okay. So switch 1 in Montreal, switch 2 in Toronto, so router 1, router 2. They are booting up. as you can see. So I have to connect back again to my topology. Okay, so my routers are booting up. I have put the IP addresses here for simplicity, so I'm just gonna configure the IP addresses based on what I have on this topology. So I can see that my systems are booting up. I say no because I'm just gonna configure routers. So I will start with the switches. So here I will start from the switch in Montreal office. So this is R1 Montreal. So I will change the host name to, let's say, S1 Montreal. Okay, so as you can see, this is VLAN 10 and this is VLAN 20. So I have to put this port in VLAN 10 and I have to put this port on VLAN 20. That is the only configuration that I need to do on this switch. So 01 switch port mode access and switch port access VLAN 10. So VLAN 10 is created. So I'll go to this to interface 02 switch port mode access and switch port access VLAN 20. Also, I need to make this interface gig00 the trunk port. So I'll go to 00 switch port encapsulation switch port trunk encapsulation .1q and switch port mode trunk. Okay, I always save my configuration and show IP interface brief just to verify my interfaces are up. Okay, now I'm going to the Toronto. I'm going to configure the switch in Toronto office. So in this switch, as you can see, I have VLAN 30, VLAN 40, so I have to assign VLANs to these ports. So the first thing, I'm gonna put the host name switch to Toronto. Okay, int gig 01 switch port mode access and switch port access VLAN 30. I will do the same for 2 switch port mode access and switch port access VLAN 40. And also the trunk port, so I'm going to 00 switch port trunk encapsulation .1q and switch port mode trunk. Show IP interface brief. My interfaces are up and I write the configuration. Okay, now I'm going to configure this router, which is actually using as a DHCP server and also the default gateway for the VLANs. And you have to keep in mind that we have to configure DHCP and we have to configure the sub interfaces for different VLANs that we have. Okay, so also I'm gonna put the description on the ports. So I'm going to the Montreal router conf t hostname I put it R1 Montreal. Okay, I go to int Ethernet 0.10. So because I'm using the sub interface, so first I have to put the encapsulation 10 and then IP address 172.1.128.255.255, and be careful, here is 28, so it means my subnet mask is 240. Sorry, I made a mistake. It is 1 1, not 120. 120. Okay, and I'm going to do the same for VLAN 20 encapsulation .1q20, and the IP address is from the next range. Okay, and int Ethernet 00, and I put no shutdown. Okay, so do show IP interface brief, and you can see that my sub interfaces are up, and I've assigned the IP addresses. Now I'm going to configure actually this port, this serial interface, as the trunk, because, and also this serial interface as the trunk ports, because they are going to or not actually the trunk port, because we are doing the IP address. We have put the IP address on them, layer 3 IP addressing, and we are going to enable OSPF. So the actually OSPF will advertise these routes to these networks, because these PCs only know about the gateways, they don't know about the IP addresses. So in order to enable the routing between the head office and the branch offices, we are going also to use the OSPF. So I'm going to also configure these two sub interfaces, int serial 10 and 11. 10 is the interface which is going to the Toronto office. So I'll put the IP address 192.168.1.10, and it is 255.255.255.252, and no shut. And I'm going to 11, and I put the IP address 192.168.1.2.255.255.255.252, and no shut. Okay, show IP interface brief, and you can see that my interfaces, actually these interfaces are up, but I have to also enable the interface on the other side for now. .110 and 1.2. Okay, so the next thing I have to do is to enable the DHCP and give you the pool that I have decided for VLAN 10 and VLAN 20. So as you know, devices in VLAN 10 will get the IP address in this range, VLAN 20 will get the IP in this range. So I'm gonna do the configuration, IP DHCP pool, let's call it VLAN 10. So I have to put the network 172.17.10. This is the range of IP addresses I talked to you about. The default router is 172.17.1.1. I will do the same for VLAN 20, and I will change the network to 16, and the first usable IP address is 17, and the default router is 172.17.1.17. Also, I have to exclude these IP addresses, these two default routers, from the DHCP IP DHCP exclude address 172.17.1.1 and 17. So if I show run section DHCP, I can see my exclusion, the pools, and I just write my configuration. So I'm gonna do the same, show IP interface brief. Okay, so 110, it shows, let me see, show run int serial 10. Yeah, I didn't put no shutdown, so conf t int serial 10 and no shutdown. Show IP interface brief. Show run int serial 1/0. Not sure why it is showing down, but okay, so let's put also the clock rate on it. So conf t int serial 10. I'll put the clock rate to, okay, then I will configure the other part and I'll come back to it. Okay, so I will come back to this interface because it's showing down, but after I configure the other part. So I'm going to configure the same on Toronto. This is Montreal, so let's put Montreal here. Now I'm going to Toronto. So first I'll create the sub interfaces or the default gateways. Sorry, this is actually the switch. So R2 in Montreal. I put the host name. R2, sorry, in Toronto. Okay, so int Ethernet 00/30. Okay, so for VLAN 30, you can see that I have put this IP address 129 in this interface. So IP address 172.17.1.129, 255, 255, 255, 240. Oh, sorry, I forgot the encapsulation .1Q30 and the IP address 129. I will do the same for VLAN 40, encapsulation 40, and the IP address 172.17.1.145, 255, 255, 255, 240. Okay, and internet 00, no shutdown. show IP interface brief. As you can see, my sub interfaces are up. Again, the same thing here. I have to put the serial interfaces, the IP on the serial interfaces, which is going to Montreal office and the head office. So localft int serial 11, IP address is 192.168.1.6, 255.255.255.252, no shot, and I will use 10 with the IP address 192.168.19, 255.255.255.252, and clock rate 128,000 and no shot. Show IP interface brief. So I can see my both interfaces are up and all these interfaces are up. Let's go back to Montreal. Okay, I can see now my interfaces, serial interfaces are up, sub interfaces are up. Okay, now I have to also configure the DHCP the same way we configured for VLAN 10 and VLAN 20, but here we configure for VLAN 30 and VLAN 40 based on the subnets that we have used. This subnet for VLAN 30, this subnet for VLAN 40. So I'm going to configure the DHCP. DHCP pool, I call it VLAN 30. We have to specify the network 172.1. If I look at the IP address, is this one is 128. So 17.1.28.255.255.240, and the default router, as you might guess, is 172.17.1.129. I will do the same. I think I didn't put the okay, I will check it again. This is, I think, this is a trunk port. I will check it. So I will create for VLAN 40, and the network is 172.17.1.144.255.255.255.240, and the default router, as you might guess, is 172.17.1.145. I also have to exclude IP DHCP, exclude address 172.17.1.129 and 145. Show IP or show run section DHCP. Okay, and show IP interface brief. Okay, cool. And okay, let's go to switch to Toronto. I want to check something. Show run show run int show run int gig 00. Okay, so it is a trunk port. It says the half duplex or full duplex. That's fine actually, because we are using the Cisco IOL and these switches, that's fine. You can ignore this message. This is a CDP message. Okay, so for now, this portion is actually configured. Switch 1, switch 2, a switch in Montreal, switch in Toronto, and 2 uh, offices. So now we are going to, as I mentioned, we are going to also enable the IP OSPF routing. So we will be able to advertise these routes to the head office, and head office also will be able to advertise routes into, so we put them all in one area 0, all the devices, like the single area OSPF we are going to configure, and we will be advertising the routes, the transit routes, uh, and the networks to the OSPF network. So how we are going to do that? We will start by on the router in Montreal. So I go to conf-t, I say router OSPF, I use the process ID 1. There is a command, we call it the passive interface. So because I don't want some interfaces to establish the adjacency with each other, that is the transit links and the serial links. I don't want to have OSPF configured on them, like to make adjacency over the serial links. That's why uh, or actually just to correct it, I don't want to make adjacency with the endpoints, only on the serial links. So that's why I put all the interfaces as passive, and then I just enable the OSPF on these 2 links, which is going to branch 1 and branch to the head office. I don't want to establish OSPF with the end clients. So I issue the command passive interface default. It will put all the interfaces in the passive mode, but I don't want the those 2 serial interfaces, serial 1 1, no passive interface, 1 1 and 1 0, because I want to establish OSPF adjacency with the head office and Montreal and the Toronto office. And I'm gonna advertise the networks 168.1.0.0.0.0.3 in area. So this is the wildcard mask. It is based on the subnet mask. As you know, it is 252. The wildcard mask is 0.3. This is the network which is going to the network in Toronto. So I will add another one, 1.8. This is the one actually which is going to this one is going to the head office 1.0, and 1.8 it is going to the Toronto office, from Montreal to Toronto. And then I'm going to also to advertise the 172 network. So 172.17.1.0.0.0.15. It is 240. So the wildcard mask is .15. 17.1 and 17.1.16, which is for this one actually, this VLAN 10 and VLAN 20. Okay, and that is the OSPF. So show run section OS. So this is my OSPF configuration. Then I go to Toronto. I will do the same. router OS1, passive interface default, and I say no passive interface serial. So if I look at the serial interfaces, it is serial 1 1 and 1 0, 1 1 and 1 0. Then I'm gonna advertise the networks 192.168.1.4, which is going to head office 000.3 area 0. The next network is 8, which is going to Montreal. The next network is 17 network 172.17.128.000.15 area 0 and 144 area 0. Now show IP OSPF neighbors. So I can see that I have full adjacency on the serial link, which is going to the Montreal office. Still, I haven't configured on the Ottawa office. I haven't configured anything right now. So I'm going to configure the headquarter. Actually, I have two interfaces, the loopback interface. Something I have to tell you on the head office, I have to have a default static route which points to the ISP, and I have to advertise this route into the OSPF process, which I'm going to do it by default information originate. If I have one exiting point to the network and I want to advertise it to the OSPF process, I use that command, and I'm gonna do it. First of all, I'm going to configure the interfaces, the IPs, and then I will enable the OSPF routing on the Ottawa router. So this is the switch. I think I haven't opened it yet. Okay, so this is the Ottawa router. Okay, so first hostname R3 Ottawa. Okay, so first of all, I'm going to configure the serial interfaces. In serial 11, IP address is 192.168.1.1, and it is /30 252. No shutdown. I'm going to 1.2 IP address 192.168.1.5 255 255 255 252, and no shutdown. Okay, then I'm going to configure this interface, which is going to the switch and ultimately to this PC. So int Ethernet 01 IP address 172.30.1.1 255 255 255 and no shutdown. Show IP interface brief, and I can see that my serial interfaces are up and my interface going to the switch here is also up. Then I'm going to configure the default route, and actually I have to also configure one loopback 1, which is acting as the ISP. So I say conf t int L1 or loopback 1 IP address 111.255.255.255.252, and I'm going also to originate or have a static route, IP route 0.0.0.0.0.0.0 to loopback 1. Okay, show IP interface brief, and I can see that I have loopback 1 is up. Now I'm going to configure OSPF, advertise the routes, router OSPF 1. So I have to advertise the routes and also the loopback. So I'll put the router ID like 10, 10, 10, 10. I'll say passive interface default. Then I say no passive interface serial, the two serial links that are going to branch 1 and 2, serial 1, 1 and serial 1, 2. Then I'm going to add the networks, network 192.168.1.0.0.0.0.3, area 0, network 1.4, which is going to Toronto office 3, and 172 network, which is going to the switch in the head office 30.1.0.0.0.255, area 0. And the important command, default information originate, to actually to advertise this route 1111 to the OSPF process, so they will be able to ping the ISP. That's all the configurations that we have for these routers, and for this switch actually we don't need, just we need to configure this IP on the interface of this. So I put the right command. Now just to make sure that conf t, I say hostname HQ or switch HQ, show IP interface brief. Okay, my interfaces are up. I'm not defining any VLANs on this. Okay, now right in Ottawa router also save my configuration. Now I'm going to turn on my PCs. They should get the IP address from the DHCP server, and they should be able to communicate with loopback 1 of Ottawa, which is the internet. So I'm going to check one by one. So first I start with VLAN 10 and VLAN 20. Okay, so VLAN 20, I think it just restarted. That's okay. First, I will check first VLAN 10. Maybe I'll just stop it and run it again. Start it again. So let's check VLAN 10, and I'm gonna, okay, so gonna check if it got the IP address from the DHCP server, which is R1 Montreal, and then we will check the connectivity. So it should get the IP from this range. So if I go to the Ethernet, change adapter options, I go to the network setting, and I can see that I got the IP address from the DHCP server in 1.2. Now just check without connecting to, let's check VLAN 20 also. So okay, so I'm gonna connect to the machine in VLAN 20. This is VLAN 20. Now I will check then from VLAN 10 to VLAN 20, and also I will check the connectivity to the ISP. So okay, this one again restarted. That's okay. So if I go to the network, and I can see 118, this is the IP I got from this range. And now let's check if we can, for example, ping. I go CMD. So wait for the CMD to pop up. So still okay. So let's see. I'm sure that VLAN 10 by now is up. So IP config. So I can see that it got the IP address from 118, the first IP in the range. So I should be able to ping 172.17.1.2, which is VLAN 10, the first IP in this range, VLAN 10. So I'm not sure. Oh, something also I forgot, or you should always remember to turn off the firewall, otherwise you will not be able to ping. That's what I need to do here. So let me just close this, guys. Go here. And I have to do the same, like on VLAN 10. I'll just check between VLAN 10 and VLAN 20, but if it works, hopefully it will work also for VLAN 30 and VLAN 40. So I'm gonna turn off the firewall. So I'm gonna connect to VLAN 10 PC. So VLAN 10 PC. Okay, so I'm going to turn off the firewall. Okay, now let's go to VLAN 20, the PC that we were pinging. So as you can see, 1, 2, now I can ping. And let's ping 1.1.1.1.1, and you can see that I can also ping the ISP. So if I go to the routers, for example, in Montreal, and if I issue the command show IP OSPF neighbors, so you can see that I have full adjacency between the router in Montreal and this 10.10.10 is in the head office. Show IP route OSPF, and these are the routes. This is the external route, which is 1111, the default route, which is going to the ISP via serial link 11. This is going to the head office, and these are the IP addresses from the other branches and also the head office. So if I also turn on this one, I should be able to ping this PC. So I'm going to the head office, or even without connecting to it, I can just check. If I go, for example, to VLAN 20 and ping the IP address 172.30.1.1, 172.30.1.1, and you can see that I can ping it because I have advertised this route into the OSPF. Let's check with VLAN 30. I'm not gonna check VLAN 40, just VLAN 30, and I will finish this video. If I'm getting the IP address and I can connect to the ISP, so it means, and I will also ping VLAN 30 to VLAN 40 and the ISP and this PC. So just I have to make the turn off the firewall, and as you can see, I have the IP address. So if I go okay, change adapter options. So VLAN 30 should be in this range, 129. So the first IP address should be 130. Okay, and as you can see, 130, I got the IP address. I'm gonna turn off the firewall and ping both the ISP and VLAN 10 or 20, and let's have this sanity check. So turn it off. Now I go to CMD. So 12 and 118 are the IP addresses of VLAN 10 and VLAN 20. Okay, IP config. Okay, 130, so I'm gonna ping 172.17 just 1.2, which is VLAN 10. I can ping it. 118, which is VLAN 20. I can ping it. And let's ping, sorry, let's ping the ISP 1.1.1.1. I can ping, and the last one 172.30.1.1, which is the head office PC. Okay, so we check the connectivity in this lab. We configure the access switches, we configure the routers as a DHCP in both branch offices, and then we check the connectivity between the branch offices, the head office PC, and the ISP, and also we are running the IGP OSPF to distribute routes between these two all subnets. Okay, I hope you enjoyed this video, and I'll see you in the next video. Thank you very much. Bye.